Greetings and welcome, internet friends. We were talking about proving triangle congruence by the side-angle side congruence theorem. The big trick to this particular theorem was having two sides in one triangle congruent to two sides in another triangle, and having an angle that was congruent to the other angle in the other triangle. But the special thing was that this angle was just like this A is between those two S's. The angle had to be the included angle between the sides. The angle in the armpit, if you will. So, for question 4, it was, hey, how about that PK? How about that LK? So the PK and the LK, the included angle would be this one right there, right? So I could call that angle L, KP, right there, right there. And actually, I knew that the vertex had to be at K, because both of those segments had that right, as a point, an endpoint. And actually, it would make sense that the other points would have been the L and the P. So I theoretically could have labeled this without a diagram if need be. So for instance, here, I know L is the vertex, and it's probably going to be a K and a J on the other sides. But let's check visually and see what happens. So here's the old KL right there, and the JL right there, and so this angle right there, JLK or KLJ, either way. Oh. All right, so here we go. I've selected a hodgepodge of problems for us to look at of varying difficulty. So check this out. I've got, can I prove these triangles congruent? So right now, I know this side and this side are congruent. I could show that if this is perpendicular to that both of these are right angles by def of perp. By right angles congruence theorem, I could show that those two angles are congruent. Could I get a third side here? Anyone see a third side I could show as congruent? Or, yeah, ZX. Sorry, I actually did kind of say that weird. I could show that this is congruent to itself. For my second pair of sides, and that would be congruent by reflexive property, which is one of the top 5 frequently used reasons for proving things in my geometry class. Reflexive, that E is like so relaxed, or like relaxed, not reflexive. That it's just like that E is just laying down, taking a nap. By the way, Wadi Math official sponsor of Wadi Math is Naps. Highly recommend it. So checking this out now, notice I've got a side, and the included angle. But on this triangle, I've got side, and a non-included angle. So this one's actually a no, because I didn't have a side-angle side arrangement for both of those. Those two triangles were not congruent to each other. Or I guess maybe they could have been, but I can't prove them congruent. And actually, no, I take that back. They're definitely not congruent to each other. I would have the ability to prove they're not congruent. But nonetheless, I digress. The idea here was that this was the non-included angle. Right. Okay, how about for the 14? I've got 2 sides already congruent. Right, so for side angle side, I've got that. Anyone see something else that could help us out? Yeah, that was given information, the parallelity. I think I heard someone say something about this. Not necessarily. But KM is congruent to itself by reflexive. So that's another side. So I'm on the hunt for an angle here. Now that parallelity, I think that's going to help us out. I think I could do a little bit of I don't think I could deal with those. I don't have the transversals don't behave that way yet. Yeah, I think I could say something about this angle and this angle, right? By alt int for question 14? Oh, I don't know. I just drew it. I don't know. There you go. So now the question is, I've just got an angle. Is this the included angle between the sides? Look at side, side. The included angle would have been here. So this is a non-included angle, which would have been like this. And that is non-existent. Uh-oh, that's not a geometric theorem. That's not appropriate for children. No. There's no such ASS theorem, friends, because mathematicians are going to keep their mouths clean, tell you what. And also, it's not true. ASS doesn't work as a... I'll disprove it for you at a future date. All right. Oh, sweet. Got some proofs here. Look at this. I made this nice little fill-in-the-blank proof. I was thinking of Blanca from Street Fighter, actually, but that's okay. You can leave that. Just leave it. So these two are congruent. I like it. These angles are... Oh, I don't actually know those. Hey, internet friends, we just heard that the mover bus is going to arrive right now, which is actually a couple hours late. On my ride into work today, there were power lines down in the road, but I was like, you know what? Electrocution is worth the risk of teaching students shapes. Not if I drive into the wire and it's touching the metal top. Well, but I thought you guys were worth it. Also, shout out to the mover. Go check out the moover.com. Mr. Waddy regularly rides the mover when it's snowing, but it is not considered a snow day. So shout out to the mover, getting Waddy to math class regularly through the winter season. So, student just asked, how strange is it riding with students? A little weird. I ignore the erasers that get thrown on the bus. I just put my headphones in and listen to podcasts. So, back to this problem, friends. So notice this. I have one pair of sides congruent. I have a feeling I'm working towards a side angle side here. So that's the yellow part. I happen to know that PQ is an angle bisector. So if that is an angle bisector, I think that's going to help me out right here using the definition of angle bisector. Oh, we're almost there. Yeah. I'm going to finish this one even though I'm doing it out of order, I realize. So notice this. These two angles are congruent. What could I name those angles? What's a name for this angle? Don't worry, friends. I can't call it angle P because there's too many angles that meet there. I'm a fan of SPQ. So SPQ and TPQ. So right there, those two angles are congruent. And hey, those are a pair of angles, so I'm going to put that in the blue right there. That's that little fact. And I'm looking for a side using reflexive, which, yeah, my friends, two of my friends with the shout out right there, they said PQ is congruent to itself. Yeah. I just called you one of my friends, and you didn't disagree with that part of my statement. I don't know. That it was just a sad cue. All right. And so that's my second pair of sides. So notice side angle side. That is in order. So I could prove triangle congruence using the side angle side congruence theorem. Right? I don't know. It's just our brains whirring up as we're thinking about geometry. All right, question 17. Question, comment? No? All right. So here, let's take a gander at this. It says C is the midpoint of A, E, and B, D. So, using definition of midpoint, I bet, oh, you know what? I bet the book probably would have fit two separate claims here. That's a little sneaky sauce right there. So I think I could say Assassin's Creed is congruent to Charlie Echo by definition of midpoint. So that's going to be one of my sides. I also could say BC and CD are congruent for the same reason, definition of midpoint. Okay, so BC congruent to the CD, also def of midpoint. So this one fact fed both of those right there. And so that's two sides. Now the question is, friends, could I get myself an included angle? Oh, so that said ACB and ECD. That is what's going to go there. How Hawaii? Vertical angles theorem. One of the top 5 frequently used reasons for proving things in Waddy class. So that's my angle, and it is in fact in the in-between of those sides. So that's my side angle side. We're done. And so these triangles are now congruent. Right, we didn't know it before, but now we know it, we proved it, we believe it. Well, there are situations in which they might dupe you. They try to trick you. Yeah. So be on guard. Be on guard. Yes, question? In a measurement? Like, okay, so if I started to know, like, if I knew BC was 90, then I would know CD is 90 by def of Cong. Yeah. So I could start then filling in information. And then also later on in 5.7, we'll talk about the fact that once I know the triangles are congruent, then I would know the remaining corresponding parts are going to be congruent. Let's see. I'll take a look at it a second. So this one, was because this was a right triangle. It just had a hypotenuse that was blue units long. This one didn't. Yeah, so they wouldn't have lined up. Did I have any more? Oh, how many do I have? Oh dear. Okay, I've got to pick up the pace on this video. All right, this one, speed run it. It's a square. Definition of square. It's a type of rhombus. All sides are congruent. I also know that a square is a rectangle, so all of the angles are 90 degrees. By right angles congruence theorem, all of those angles are congruent. What do they want us to do? What were the directions for 20? I didn't write. Oh, see if I can show that. Okay. Oh, and look at this. I've got a side, I've got an angle and a side, right? And so I think I could show those triangles are congruent. Let's name them triangle ABD. And you could have named this 6 different ways. So ABD is congruent to CBD. I actually also could have said this one because the triangle has some isosceles-ness to it. By side angle side. Cool. All right. Check this one out. Here, speed running. Go. Regular pentagon. The fact that it's regular means all of its sides are congruent. And it also means that it's equiangular. So that means this angle and this angle and this angle and this angle are all congruent, because that's part of the regular meaning of that word. So I think in terms of proving triangle congruence, sorry. I've got triangle stew is congruent to triangle UVR. Beep, beep, beep. Notice I've got a side, and 2 sides in the included angle, right? 2 sides and the included angle. So that's side angle side. Side angle side. I don't think I could prove anything else. Although, today, foreshadowing, we'll find out that, actually, do I have a way to show that? Maybe not. But this middle triangle we would end up being able to classify as isosceles. Yeah, actually, no. I could have showed this by, if those green triangles are congruent, then these 2 sides are congruent. And then, yeah, this big one is isosceles. All right, last question. We did one of these yesterday. I'm going to speed run it right now. So just sit back, listen to some smooth jazz, watch the machinations of geometric construction. And for fun, I'm going to intentionally make this not arranged in the same order. So let's say I want to figure out, all right, I don't want an oval. So I draw a ray with my new point. I mark this. Here, my friend, here. Sit down, quiet, don't distract, but enjoy as geometry happens. So look at this. I draw a ray. By swiping that arc there, this would be my Charlie prime. Those are definitely congruent segments, AC and A prime, C prime. Thanks. And then, let's see. I want to... I've got to do the angle part now. That's the tricky part right here. So let's say I want to duplicate angle A. So I recenter at A. I'm going to resize this. So this is just an arbitrary arc like that. I'm going to duplicate that arc right here with a generous arc. So that way I know it's going to meet the obtuseness of that. And to finish constructing the angle, I actually line up my crosshairs at the intersection of that arc and one side, and I resize it so it meets the intersection of the arc and the other side. Actually, tell you what, I'm even going to do this in per play. Yeah. Oh, guys, ha! I almost did it wrong there. That scared me. I lined it up at A prime, but I've got it right here. And so this intersection, all right, so here's the purple center, purple arc, purple arc. Oh, thank you. Welcome back, fellow mover rider. I didn't knock the power line down. Yep, definitely wasn't me. But when I kept driving down the mountain, I did flash the headlights at everybody just to be like, look out, there's a power line down. And then I drove by the fire trucks and I saluted them. Actually, I didn't really salute them, but I was happy they were out doing their jobs, and I was like, I'm gonna get to school and help the chillins learn the geometry. Okay. So guys, so I've got congruent side, congruent angles. The last thing I need to figure out is how far is B from A. So I'm going to center at A, scale up the AB units away, and I'll center at A prime, right? And swipe that arc like so. And so this will be my B prime. And all right, this video, yeah, hopefully you fast forwarded through this. Here we go. I'm gonna trace out this triangle and we'll test it. I agree. I think everyone cries at the end of Waddy Math videos because they're like, that's the most beautiful math I've ever seen. Ooh, tell you what, let's even, ooh. Matty Waff. So guys, check this out. The claim is that this triangle is congruent to that triangle. Let's see. Looks something like that. A little close, little off. If you blur your eyes a little bit, we'll pretend it works. Well, thanks for watching, internet friends. Adios.